Okay, you all are able to see my screen?
Yes.
Okay, good afternoon, everyone. Today we shall see the inheritance which we started last session. We all know now that inheritance is deriving the properties and behaviors from one class into another, right? So the class from which you derive something is called as base class or parent class. And the class into which you derive the properties and behaviors is called child class or subclass, right? So by now I'm sure if you've gone through the assignments, it's clear that what is class, what is inheritance of a class. However, there are a few things we need to look at. The member functions, how we define, will decide how the subclasses will make use of them, right? So the for the properties of the base class to be accessible to the subclass, we must use protected access specifier. We have seen this, isn't it? So any data member you want to be passed on to the subclass, then it should be declared as protected, or the access specifier for that particular data member should be in the protected section. And subclass can have its own properties in addition to the base class properties, and also it can add its own methods. Now coming to virtual functions. Now C++ has a keyword called virtual. If you prefix that with the method becomes virtual method. It means the same method can be overridden in the subclass, and the behavior of the method depends on which object that pointer is pointing to. All right, so we shall see some of these implications when we see an example. So let's consider an example of a car. So car, we can add few data members like car name, and the constructor will initialize the car name to certain value. Let us say there is a method called as start car. Now, this being a car in general, it is not a particular car. If I say start car, I am just putting out a message saying starting something. Okay, and this is the base class for you, and from this I derive a specific car. Let us say Kia, or any brand you can take. Class Kia is deriving from the base class car. Now I'm adding one data member called technology, which is a string. Now what I do is I initialize the object of this subclass with a parameter cn for the car name, and tech as the technology which is to be used to initialize the subclass data member. Now using the first argument, I pass it on to the base class to initialize the car name, and second is used to initialize the data member of the subclass. And here I am writing the same method start car which I've defined in the base class. Is it allowed in the first place? And if yes, what are the implications? Right? In C++, this feature is added, that is subclass can be overridden by the subclass. I am using the term override. Override means redefine the same thing, exactly same signatures. If it is void here, it's void here. If it is same name here, same name here, and no arguments here, no arguments here. Remember, this is not method overloading, that is different. Some time back I mentioned about method overloading, right? Overloading means at least one argument should be different. There are no arguments here. If I add one argument like int x, something like that, then this method becomes overloaded method. Okay, normally overloading is done in the same class. Okay, but when you override, it is between base class and subclass. Now this method, if you override, you must include the keyword virtual here. Now if I don't include this virtual method, what happens we shall see during the implementation. Okay, so now after defining these two classes, we come here to instantiate object of the car class. Now if I say car star C equal to new car, some car, I'm just giving some name. Okay, and if I say start car now, obviously C is pointing to car object. It will call the base class method. All of you agree? So if you see this, I am creating an object of car, and when I say C arrow start car, obviously same class object is created and same class reference variable is pointing. So this method is called, and you should see output as starting somehow as the output. Okay, but the same reference variable which is of type car can be made to point to the subclass object. As you can see here, C equal to new Kia. Kia is the subclass, right? And I am passing the name of the car as Sonnet and technology as electronic ignition. And now if I call C arrow start car, this should call the subclass method which is here. Okay, so this kind of arrangement is called as runtime polymorphism, right? Polymorphism because the start car name is same, the method name is same, but what it does depends on to which object it is pointing to. Here it is pointing to the base class, so it will call base class method, and here it is pointing to the subclass, same reference variable pointing to the subclass. Now I am executing the same method which I executed here, so the behavior will be different depending on where C is pointing to. So that is why it is called as runtime polymorphism, because until you execute all the statements and come to this point, you will not know where this C will be pointing to. At this point, C is pointing to the subclass object and subclass method will be called, right? So we shall see all of this in action. We'll write the code and try to see how all these things work. So is my screen visible?
Yes.
Okay, so just pay attention. I define the base class here and add a data member car name and add in the public section the constructor of car. I'll give some car name because at this point in time it is some generic car. Okay, and then we'll add one method start car. And here I say car started somehow. I do not know what technology is using to start the car. So I'll just write like that. Okay. Now, since I want to derive this car name in the subclass, I can use the keyword protected here. Isn't it? So the car name can be accessible in the subclass. So after having defined the base class, now I define the specific car which is derived publicly from the car class, and here I will add one data member technology. So this will hold what is the ignition technology that used. There are many ways to start a car, right? Electronic ignition or piezoelectric ignition, all right, or any other type of ignition that you might have. Okay, so this will be initialized by the constructor of this new class. So in the public section, you add the parameterized constructor here, string car name and string tech. Now these two I'll initialize using the, now here I will call the constructor of the base class Okay, I need to define the parameterized constructor also. And here I'm going to add technology as tech. Okay. Now we need to add the parameterized constructor also if I want to initialize the car name. Okay, so the base class is ready, subclass is ready with the constructor. Now I have to override the method which we have in the base class. Void, again I'm going to write start car only with no arguments here. But I know how I have to start this car. Okay, so since car name is accessible here because it is protected, you can say is or has started using whatever is the technology and okay, so we have both the classes ready now. So in the main, what I do is I create a reference variable of car and use new operator to create an object of your base class. And now if I say C arrow start car, let us see what happens. So what should happen? Your reference variable C is pointing to base class. Obviously base class method would be called and you will see car started somehow should appear here. Alright. Okay. Now the same variable I can make to point to the subclass also. Here I have to pass the car name. Let us say Certos. And then technology, let us say I use piezo electric ignition. Okay. Now if I execute the method start car, just observe both type of cars have the same method start car, but the way Kia car starts is very different from your dummy car which is as a base class. Now if you see first line will be car started which is coming from the base class. Yeah, now I have not used the virtual keyword. If I don't use virtual keyword, this is what happens. It doesn't recognize the overridden method. Right? It will again call the base class method only, even though C is pointing to subclass object here. Do you observe?
Yes.
Okay, now if I go and change this to virtual, if you have redefined this method in the subclass and you are invoking that method, now you will see a difference. Okay, first one is coming as it is, car started somehow. Certos has started using piezoelectric ignition.
Sir, actually, C is of type car, right? And Kia, and then after C is equal to new Kia, now this C is of type car, and you are calling the child class of type Kia.
Yeah.
So, is that feasible, or will there be will there should be error or not, or
Yeah,
why
this
it
is
is
very much feasible. The program is running, right? Now just
right?
observe C is not an object of car, it is a reference variable. C, I'll
Okay,
just write here. C is a pointer, it is not object.
but type is car, right?
Yeah, true. That is what all OOPS languages allow base class pointer to point to subclass also.
Oh, okay,
Okay, so
okay,
this is a built-in feature of most object-oriented programming. Even in Java, you have base class reference variable can point to subclass object. Okay,
okay,
so C
okay,
being a pointer, it can point to either base class or subclass. Otherwise, if this feature is not there, then you cannot implement polymorphism,
okay,
isn't it?
okay.
In that
Yeah,
case, you have to take a separate pointer for the Kia car,
yeah,
right? Here you
right.
should say Kia star C1 something.
Is equal to, yeah.
Okay, so you cannot execute polymorphism. So using the same base pointer, I am pointing to subclass object, which is very much supported, and that is why you see if I make the base class method virtual, the subclass will override that, and the subclass method is called. This part is clear.
Yes.
Now, what happens if the subclass definition is not there? Suppose if I remove this.
Parent class.
Let us see whether that happens or no. So, if the definition does not exist, the parent class method is called automatically.
Even though we are not defining it,
Yeah, we have not defined it. So,
okay.
in that case, it will use the base class definition only. I mean, you have the freedom to redefine it or leave it. You
Okay,
getting my
okay.
point?
Yes, sir.
Yeah. So, if you redefine, it will call the redefined method.
Okay.
Okay. So, this is one very good feature of C++ or any object-oriented programming, that you can redefine the methods, because how an individual company can implement technology depends on that company. For example, if I have another class here, let us say your Maruti, which again derives from car. So it almost has same things here, string technology, let us say, and in the public this thing we have constructor with two argument, car name and technology. I pass it on to the base class the car name and initialize the technology here. I will use just tech here otherwise. Now, how Maruti car starts depends on their strategy. If I say start car here, and here when you create object of Maruti car, the technology used may be electronic ignition. So let's see whether that can be done. So I create an object of this. Let us say Maruti model Brezza, and then here I say electronic ignition, right? And now if I say see arrow start car, since we have the method virtual here in the base class, it is redefined in the subclasses. So Maruti should start in its own way. So if I run this program, you will see, yeah. Now as you can see, the Kia is starting with piezo, and Maruti Brezza is starting with electronic ignition, right? So one interface, many implementation. That is the idea behind polymorphism. That freedom should be there, no, with car manufacturers, what technology that they use, isn't it? Even in software, when you're developing, there could be one method implemented by one developer in some way, another developer may implement the same method in a different way, depending on whatever logic that he wants to apply. Would you like
Sir,
to try this out?
Sir, can you please just go through once briefly, like
Okay,
whatever you explained now on
all right.
polymorphism?
Now, all object-oriented programming languages support what is called as polymorphism. Polymorphism means
Okay.
one thing behaving in many different ways, depending on how it is implemented.
Okay.
Okay. So in the base class, there's a generic car where some data member is there, which will be derived by the subclass. So that's why I put it in the protected section. And in the public section, I'm initializing the data members, one through default constructor, one through parameterized constructor.
Parameter.
Yeah. And I have one generic start car method. because this is a general
Okay.
car. I don't know how I want to start it. I just say car started somehow. Okay.
Okay.
So you do it anyhow. By default, you may be starting with electronic ignition. That is also fine here. But the
Mm.
subclasses can define start car in their own proprietary way,
Okay.
in technical words, because they might be
Mm.
using different technology. So depending on what
Okay.
technology they use, that is why I've taken one data member technology here,
Mm.
which will be passed in the main depending on the car. So here,
Mm.
this Kia constructor will initialize its own data member through this inline initialization, and it will call parent class constructor to initialize the car name. And then start
Mm.
car I have to define in my own proprietary way that how I want to start it with what technology,
Okay.
right? Either you can hard code like car has started using you know piezoelectric ignition, or you use the data member to tell how the car has started.
Mm-hmm.
Okay, so I have made it more general that I can pass the technology depending on what I'm
Okay.
passing into technology. Accordingly the car will start.
Okay.
Okay.
Sir, when we do here, right, this public car,
Hmm.
so this is like class Kia is like a child
Yeah, it's a child
class,
class.
right? That means it's a child class.
It's a child class.
Okay.
Similarly, Maruti is the child class of
Child
car.
class.
Yeah.
Okay. That inherits. Okay.
Again, it is having a data member technology only. Public is again
Okay.
constructor is similar to what Kia has, and the
Okay. Sir,
method is also
here,
exactly same.
sorry to interrupt, sir,
Yeah,
but I did not get the difference between. See, we are using child class,
yeah,
so we already have this method.
yeah.
I mean, the class, sorry, child class.
Okay.
So, how does polymorphism comes into play here? What is the added advantage?
Yeah.
I did not understand.
See, imagine you are a car manufacturing company, and there is a body at the central government level which tells that you have to build the car according to certain standards.
Okay.
If they only dictate everything, you will not have any freedom to use your own methods of building
Okay.
your
Okay.
car.
Okay.
So what they say is your car should start.
Okay.
How it starts, you define,
Okay. Okay.
isn't it?
Mm.
That is
Mm.
more practical,
Okay.
because you cannot
Got it.
dictate to Kia that you start your car with
Mm.
piezoelectric only. That may be a very expensive technology.
Okay. Yeah, got it. Each child classes can have different use different technologies.
Technologies
So
to
okay.
implement.
Implement. Okay.
Yeah, I have taken some example like this. In many
Okay.
other
Okay.
scenarios, every
Mm.
child class has its own way of defining a method which is declared in the base class.
Okay. Okay.
I am just taken only one method. You can have top car also here.
Okay.
Okay,
Mm.
that also can be virtual.
Mm. Okay. So we need to use the polymorphism. So we need to declare the function as virtual, right?
Yeah.
Okay.
Now, stopping car doesn't require any technology. You just have to switch off.
Yeah.
So
Okay.
you
Okay.
don't define this in the subclasses. So it can be,
Mm.
and it need not be virtual.
Mm. See, even if we declare as virtual, we can still call directly, right? That function.
Yeah, yeah,
Suppose we declare we don't have, but we are not modifying anything.
yeah,
We are just calling that
yeah.
function.
That will
Stop
be
the car.
called.
Yeah.
Okay.
But no, yeah, no use of for virtual. Okay.
Yeah. So now just observe this one, that to
Mm,
stop a car you don't require any technology, right?
mm, mm.
You just have to say car stops.
It's
Whenever you stop car, car stops, right?
yeah.
Now I'm not defining it in every child class, because
Child
stopping
class.
car is
Correct.
same for all cars. No.
Yeah,
Now
yeah. Mm,
here it is pointing to Kia car. If I say stop car here,
mm,
it will use the base class method. I have not defined it in the subclass, right? Stopping the car.
yeah. Mm,
Here also, if I say stop car, so in both the cases, same method is called,
called. Yeah.
because
Okay.
stopping car doesn't require any technology. Just
Mm,
turn
mm,
your
mm.
key, yeah, car stops, same method base class. So that is why there is a freedom to define some methods as virtual, some methods as normal
Okay.
methods,
Okay.
right? If anything is to be overridden by the subclass, make it virtual. So that subclass have the
Okay.
freedom to
Whatever is
redefine,
written on the, yeah, okay.
right?
Okay.
And if you don't
Got
want
it.
to redefine it, keep it as it is.
Okay.
Okay. So even if you
Thank you.
redefine this without virtual key, it will not be executed. It will always call this only because you are using the reference pointer of car.
Okay. I mean, suppose I declare one more method here with the same name in the child class.
Okay.
So you're saying it will still go back to the main class,
Yeah,
parent
main
class?
class because it is not virtual.
Oh, okay. Okay.
Suppose if I write star car here, stop car here,
Mm.
and let us say I give some other method, some other message here, stopping by turning key. To off position, whatever. So this message will not come now because even though it is redefined, the base class method only will be called
Okay.
because it is not
Okay.
virtual.
Okay. Okay.
See again, stop car stops only will come.
Okay. Yeah.
But if you want to redefine, make it virtual, and
Okay.
here that will come as required.
Okay, sir, is there any way so that my what if I want to call this
Yeah, if you
inside the
want
class
to call
to
this,
create its own object and call?
yeah,
Is
you have
it?
to create object of Kia and with its
Kia.
own reference and call this.
Okay, okay. Yeah, okay,
Okay,
sir.
you cannot
Thank you.
use base class reference to call non-virtual methods.
Okay, okay.
This part is clear. You want to try
Yes,
this
sir.
out? I will give more examples of this kind. Like for example, you have a remote, right? Remote is just remote. You may have Sony remote or Tata Sky remote. So how you increase volume, decrease volume depends on what technology you are using there. If you are using infrared, that is how it will increase the volume. And if you are using Bluetooth, so understand the concept and try to implement these things so that you know exactly what you are doing.
No, sir. She said she won't be able to join.
Okay. Okay. So she was asking about lambda functions and I am
Yeah, we all need lambda
yeah, yeah.
functions.
So I am coming to
For
that only.
especially yeah,
Yeah, I'm
okay.
coming to that only. It's a very interesting topic. Let us see what lambda functions are. So as you can see, they are anonymous functions. It means they will not have a name. Okay. And normally they are short functions, one or two lines inside them, and they are inline functions. You know what inline functions are. Okay. Now in C++, how do I define a lambda function, right? So there is a keyword function that you must use, and in angle brackets, you must indicate what is the return type of that lambda function. And in the opening bracket, you should indicate what are the arguments that you are passing to the lambda function. Okay, for example, you have int add a comma b. You know that return type is int. A and b are also int. So you would declare add as int bracket int comma int angle bracket, and here you use a object name. This is not the function name. This is called as object name because lambda function is a object. It occupies space in memory. Okay, and you start with a square bracket on the right hand side, right? Now why this square bracket is required, we'll see subsequently. And then here you indicate the actual parameters that lambda function takes, right? Type of the variable and the variable name. Then again, second data type and its variable name. And what is the value it is returning. So arrow int, even though you have indicated all of this here, you have to do it once again here. Only thing is this return type is optional. You can skip this, right? And it knows how to infer what is the return type given this return type here. So for clarity you can include, but you can arrow and int you can remove. And within the body of the lambda function you do what is required, like what operation you want to perform. Here the name of the object is add, so it is adding two numbers. Okay, and sometimes using this function keyword and specifying all this is bit lengthy. So what C++ has done as an improvement, it has provided a keyword code as auto. It means it automatically infers the return type. It also infers what are the arguments that you are passing, okay, and their types. In fact, there should be one more bracket here which is missing. Okay, so as you can see here, auto add equal to square bracket int a comma int b arrow int flower bracket return a plus b. This r should be small. So the general format of a lambda function is capture list. So what is this capture list? We shall see. Normally these lambda functions are written inside a function inside a class. So whatever is inside a function, some variables or some arrays or whatever that is there inside a function, if you want to pass, that can be passed in the capture list, that is in the square bracket. And then you have the parameter list and return type and all that. Okay. So we shall see how we can build a simple lambda function and demonstrate. Right. So initially you may not pick up what I've explained so far, but if you see through an example, it will be pretty easy. So let's see a lambda function definition and how we can use it. So you can define lambda function outside main or inside main. So I will show you how to define it inside main. Let us say I want to define a lambda function which will simply add two numbers. Okay, as I told you, I can use the keyword auto and then say add. This is the name of the object and then a square bracket, and within round brackets you indicate what are the arguments and their types. I need not specify the return type. As I told you, I directly write opening closing flower bracket and end that with semicolon. That is important. And then here is a return a plus b. So this is what is lambda function, right? Now how do I call this? Right, I simply have to call this by its name. Since it is returning something, I say cout add 5 comma 6. So it will go here, take 5 into a, b 6 into b, and add and return this. All right, now if I run the program, 11. I mean, you might all wonder what great things we are doing. You are simply writing a simple add function in a more complicated way. Okay, so there are many important applications, especially in testing to implement mock tests it is used. I'll demonstrate that. But in a very simplistic sense, this add function is taking two arguments and executing the instruction and returning the result. Now, as I told you, the capture list, suppose you have a variable here, let us say x equal to 7, 8, whatever. If I want to pass this to the lambda function, you can pass it here. And let's say along with a plus b, you want to add x also. Then in this case, even if you are passing 5 and 6, the result will be 5 plus 6 plus 8. Okay. Right, so it is 19, right? So this is a place where any environment, I mean, lambda function is in the environment of main function. Whatever variables which are there, you can pass them. For example, if you have an array, okay, let us say, you can pass the array also. All right, and whichever element of the array you want to add, let us say 2 here. So 0, 1, 2, 6 will also be added to this. So result should be 25. right? So as you can see, we can write lambda functions which are very short and do some such thing. Now, here you cannot really appreciate the usefulness of a lambda function. Let's take a more useful example. Let us say I want to write a lambda function which will square the number. Okay. So in this case, I know I'm going to pass only one variable, and then I'm going to pass this to the body and square it. So this is also lambda function. There should be a square bracket, that you must not forget, right? If you don't specify square bracket, it gives error, right? So I can check it's working using square it and pass some value. So what should happen here? I should get 25. All right. So just to take it to the next line, I can put one handle here. Okay. So this is square it. Now, can I write a qubit lambda function? Yes. Auto qubit equal to square bracket argument x, and then in the body you just say return x star x star x. This is q. So some 81 it should return. No, 27. What happened? There should be a semicolon here, as I told you, otherwise it will give error in the next line. So 3 into 3 into 9, 9 into 3, 27 should come. Okay. Okay, so any lambda function that you want to define, you have to use the keyword auto. This is the first thing. Okay. And give some name to that lambda function. You call it as, it should be a relevant name. For example, you want to say greetings. Okay. And after this, you must put a square bracket and then round bracket to indicate what you want to accept as an argument. Let's say I want to accept a string, let us say message. And here you just want to see out the message. This is the simplest lambda function. And you must put a semicolon here. Okay. So keyword auto, name of the object, and equal to, after equal to, you must put a square bracket here. Okay, and then in the bracket, what is the argument type that lambda function is expecting? Okay, and what is the return type? Return type here is nothing. It's actually void. So you need not indicate that here, right? It is optional. You can write void here, but that is not required. When you say auto, automatically it will infer what that function is doing. Now, just to call that function, you say greetings. And here you have to pass some, let us say, good morning or good afternoon. Okay. So if I run this program, you will get the output. Correct? So this is one simple example. The other one I showed you, add two numbers, square bracket. Here I am going to pass two arguments of both type int and then flower bracket and return a plus b. And here if you want to call this lambda function, you just have to say add 6, 7. And since it is returning a value, somebody should display that. So you say cout this. Right? Yeah. Now just give a try for this small thing. We'll go a little slow because this is something unusual kind of programming. I don't want to get you to get confused somewhere. Just try very simple lambda functions. one displaying greetings, another adding two numbers. After doing this, if you can show me how to write squaring a number, you show me that as a lambda function. Yeah, see, I told you that you can pass a value to the lambda function through the square bracket. Okay, and if you see the definition here is called as capture list. So let's take one example where I want to use a capture list. Let us say I want to display marks with some grace. Auto marks with grace. Okay, and here in the bracket you pass the grace marks along with your actual marks, and you can see out my final marks equal to grace plus marks. Okay, and this grace you have to define it here. Int grace equal to, let's say you want to give 5 grace marks to everyone, right? And you should end that with a semicolon, don't forget this, and you can say marks with grace, and within this you have to send the actual marks. Let's say you got 67 marks, so it will take 67 here, add 5 grace marks, you will get 72 marks. Now we understand the importance of a lambda function. It can be used to do some processing like this.
Also, one thing like within the body of that lambda function,
Yeah,
can we modify the grace?
yeah, you can subtract one, or you can change it.
No, grace equal to something.
Grace plus equal to 2, like this. You can. So now what happens is 7 marks will be added. So the result should be 74, right? Oh, it doesn't allow. Okay, read only.
Grace is read only.
Yeah, so it doesn't allow.
Environment variable, it cannot be modified.
Yeah, so okay, so my final marks is 72. Yeah, so it doesn't allow the environment variable to be modified within the body of the lambda function. This much is clear? Okay. So you can try that squaring the number, auto square it equal to square bracket, round bracket, int x, return x square. This is to square the number, and semicolon. Cout square it. You can pass 6 and say enter. .36 is the answer. Could you write this marks with grace? Hello? So you can think of any lambda function which has very small computation to be done, and you can just check that. For example, let us say you have some balance amount in a bank, some 5,000, and I want to write a lambda function. Let us say debit. debit some amount, square bracket. Here you pass the balance, and whatever amount you want to deduct, that should go here. And if balance minus amount less than 1000, you have to put a bracket here so that the subtraction is done first. Then you can return transaction failed. Else return transaction succeeded. So should not pass ended along with this. Just have to pass the string. So if there is enough balance, then only you are doing this, right? So this is another example where we have a lambda function which is doing some if then else, right? So if I say debit amount, and let us say 5000 is there, if I give 3500, it should go through. And since it is returning a string, you can see out it. Okay, so I should get transaction succeeded. Right? And if I pass 4500, it should say transaction failed. Okay. So now you understand how to write a lambda function which accepts some value at the point of invoking the lambda function. It accepts some environment value like balance and do some computational logic here. Okay, so you can write one more. I'm giving more examples so that you're comfortable working with lambda. Let's say you can say compute or say get festival discount or festival discount price, whatever. Is a lambda function. This will accept the price of the element or the item that you want to this thing, and here you accept a discount percentage, right? So what you are going to do, you are going to take the price minus price into discount percentage divided by 100. And I have to declare the price here. Let's say 1000 rupees is the price. And here if you see out, get festival discount price. If I give 5% here, so price being 1000, I will get discounted price as 950. Okay, I got 950 as the discounted price. Similarly, if you want 15% discount, then 850 will be discounted price. So lambda functions are not so difficult to understand. You just have to remember it always starts with the keyword auto, and you have to give a name to that object, and then equal to a square bracket where you can pass some environment variable, and within round brackets you pass the arguments that lambda function takes. So it doesn't always take only one argument. You can have more than one argument also. Okay, you getting it
Yes,
now?
sir.
Okay. See, here the environment variable I'm passing through the square bracket. Can I pass it here only? That should be possible, right? For example, if I say price here, then tell me what all changes I should make. I should remove this, and then here as a first argument, I should say float price. This would again do exactly the same thing. Okay, so here while passing the price, you can pass different prices, but if it is coming through the square bracket, that is also fine. If normally if you want to reduce the number of arguments to the lambda function, you can keep it simple, like just pass one parameter, and the other one you can take through that square
Environment
bracket
variable.
here. See, so these variations are possible. So at least you got some uh, idea about what lambda functions are, what all they can do. And in the assignment, I'll give you a few sample lambda functions to write. So that should make your idea about lambda functions clear. Okay. So to summarize, what we discussed today is in inheritance, when you inherit, the subclasses may override the virtual functions. If whenever the subclass overrides the virtual function, then the base class reference pointer, when it invokes the method, the subclass method will be called. Okay. But if you don't use the virtual keyword, even though you have overridden the method in the base class method only will be called. It will not call the subclass method. Okay. So runtime polymorphism, if you want to implement, you must use the keyword virtual. And lambda functions are small one-line functions uh, uh, which can be defined using the keyword auto. And its syntax to define is you have to give a name to that lambda function, and after equal to you must place a square bracket to receive any environment variables, and after that you start opening round bracket and list the argument the lambda function takes. It may take one or more arguments just like any other function, and within the body of the lambda function you build the logic. It may use if loop, it may use a for loop, or it may just do some simple calculations using some expressions. Either it may return a value, it may not return a value. So that all you have to decide based on the requirement. And once the lambda function is ready, end that with a semicolon and call it by its name or the object name and pass whatever arguments that you have listed in its argument list. All right. So in the next class, we shall see a more concrete example of a lambda function inside a class. So as you all know, lambda function can be written inside main or inside any class also. We have seen classes, and within classes we have methods. Along with the methods, we can write the lambda function, and these lambda functions can be called from within the body of a method. More on that we shall see in our next lecture. All right.